Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
So, hello, and welcome to this episode of the Trend Detection Podcast. We've got a really interesting topic today. I'm covering sort of three key areas, or blending, I guess, three key areas today. So data, AI, and sustainability. And of course, predictive maintenance, so maybe four key areas. And we've got today Rob Russell, a friend of the podcast. You've probably heard him on a lot of previous episodes, especially over the past few months, but we're happy to have him back on again, of course. But for those who don't know, I'll hand over to Rob just to do a quick intro before we dive into the topic. Over to you, Rob.
Yeah, that's great. Hi, Niall. Yeah. My role within the Siemens and Senseye team is head of the predictive maintenance strategy. I also oversee our delivery team as well. And today, delivery is more about supporting all of our various regions delivering. It's been an interesting challenge over the past few months.
No, absolutely. And who better to talk about this really interesting topic today? So just to kick things off, I guess we can start quite broad, around the market and sustainability and the demand for... So I'm going to start that question again because I completely... So today we're going to start quite broad and look at the market in general, I guess. So obviously there's a lot of talk about sustainability. Whether it's predictive maintenance, IoT, it's very, very closely linked. So how does Senseye Predictive Maintenance sort of address the sustainability topic, first of all? Maybe predictive maintenance as a whole as well.
Yeah, I think the more efficiency you can actually drive in to your business and ways of working, there'll be all these natural side effects related that will have an impact on sustainability. Most businesses are going straight in trying to reduce bottom line costs, but by doing things in a more efficient manner, like maintaining machines properly, maintaining them at the right time, not consuming so many spares and consumable items, and avoiding secondary damage. These all have a positive impact in sustainability, and I'm sure we'll go into those in a little bit more detail. But yeah, it's about making effective decisions based on data, really.
Yeah, put simply. But I guess what we're not saying, and I don't know how, we can only talk from a sort of a Siemens perspective or in a Senseye Predictive Maintenance perspective, but what we're not saying is that we're a sustainability tool, but, you can purchase us and we're a sustainability tool. It's sort of, I'll let you go into that, I guess, a bit more detail.
Yeah, and I think we would describe it as like one of many sort of benefits that can come from using our technology. But you're right, we don't, it's Senseye Predictive Maintenance. It's not Senseye Sustainability. But again, is there any single tool for that? I think it's a combination of things that all come into play to aid that.
And in terms of and of course we're talking about data and AI play a key sort of part of this story as well. So I guess first of all, how do those areas accelerate sustainability or contribute to those sustainability outcomes, and can it lead to like profitable outcomes for businesses as well?
Yeah, so there's a lot of people connecting machines up, digitizing. Maybe people still talk about in the Internet of Things or Industrial Internet of Things, and there's various use cases and benefits in and around that. Obviously from our perspective, it's understanding the condition and the health of a machine, but people are investing in that for other reasons. Quality improvements and maybe things like energy monitoring that's very related to sustainability. But then once you've got that data and it's captured, making best use of that data and looking for secondary uses in that data to drive forward those other sort of benefits that you get. So maybe you've been doing this to avoid unplanned downtime, right? But then that unplanned downtime that you're avoiding means that maybe that gearbox that you're monitoring, you basically managed to save it. You just repaired it, so you didn't have to order a brand new gearbox. You now not got a scrap gearbox that's having to get disposed of in some way. these have all got great impacts on sustainability in my view. So it's more than just reducing the energy demands and the energy uses directly in the factory. It's looking upstream and downstream, and the impact that you can have. But making this a data-driven thing, building on that data infrastructure that you have, and looking for all of these additional use cases that you can build.
Yeah, and that's a key part of it as well. I guess it's about utilising existing data primarily. If there is existing data in place, right? There's a lot of value you can get from existing data.
Yeah, and it's one of the things that we sort of push on with quite hard within Senseye. It allows us to get projects started quicker, allows you to achieve ROI quicker, return on investment. So if you're not having to invest in a whole lot of new hardware, maybe what you're putting in place is some connectivity to take sensor data that already exists, maybe for control processes. And again, there's maybe a sustainability element there. You're not having to buy a lot of unnecessary duplication of sensing. You're building on sensing and connectivity that's there, so you're not wasting a lot of effort in installing new hardware and the costs that come with that, not just financial but environmental.
Yeah, and of course, like disposal of ones that need to be replaced at some point as well, of course. But
Exactly.
and in turn, and actually, that's a good link to another question, which around sort of what the data sources which are utilised for I guess predictive maintenance projects. What sort of data would we bring in to?
Yeah, so it's fundamentally what we're trying to look for is leading indicators of failure. So some people refer to them as like KPIs, but our sort of language is condition indicators. So things that time series data that will change based on the physical characteristics of the machine over time. So that could be anything as simple as like peaks in currents from a motor, could be differential pressures across a pump, could be vibration levels on a gearbox. Yeah.
And you were talking, you mentioned before about some of because when we talk about sustainability, it's such a broad topic. There could be so many different areas, which I think we should probably explore. But you mentioned like reducing energy costs, which I guess is a natural thing that people think with machines running more efficiently, less energy being consumed, etc. But what other sort of, from a predictive maintenance standpoint, what sort of, how does that impact sustainability? Some of those other use cases you said, and maybe go into more detail about.
Yeah. So there's some industries that we are working in our client base that are very energy intensive. A lot of areas related to metals production, for example, highly energy intensive. But what we can be doing is if we're making sure that upstream and downstream processes are still running, we're avoiding the downtime. You've not got waste going on where either you've been consuming a lot of energy to produce product that you're putting into a process that might be wasted, or you've not got machines that have got a high energy consumption like smelters and things like this that are having to sit in standby and just burning away energy while you're waiting for a downstream process or machine to be corrected to get a production line back up and running again. I mean, that's got a large effect. You can be much more controlled and planned. But then other side effects as well is if you're moving from a situation where maybe you might have a maintenance strategy that's like a preventative maintenance strategy where you're saying, okay, we're going to replace the bearings on this machine on a 2-yearly cycle, right? And because maybe on average they kind of fail around about every 3 years, so let's do them every 2. So you've got a lot of consumables going on there, a lot of bearings, a lot of grease, lubrication, a lot of seals, and disruption on the machine. If you can actually use data to tell you when those bearings are problematic, you can entirely remove that preventative maintenance task and shift everything to on condition. When I say on condition, it's the condition of that component within the machine, and you're replacing it just when it needs replaced. And if you were thinking, like if you had hundreds of gearboxes in a factory and hundreds of bearings that you're not consuming on a just a routine basis, this has to be a positive thing. And again, it's combined with a financial benefit, but also has a compounding sustainability benefit as well. So it's a win-win.
So I guess what you're saying as well, because obviously in large organisations, it's not just about the organisation themselves looking at sustainability, but they also the impact along the supply chain. So I guess that's what we're leaning into here is actually it's the supply chain they work with as well. In this case, obviously spare parts side.
Yeah, exactly. And getting those parts onto the shelves in the factory, that's got a carbon footprint associated with it. And if you're storing those parts, you've got facilities that need to be kept lit and kept warm, to store those parts locally. If you don't need that, you can reduce the size of your spares inventory. You can reduce the amount of components that are moving through your logistics supply chain for your spare parts. And obviously, it's those transport costs that are probably much greater from a carbon footprint perspective than maybe sometimes the manufacturing of those components. And I know from some studies that we've been involved in the past that there's a big difference between a part that's maybe just ordered through a normal process opposed to a part that maybe you're getting on an emergency order. So maybe you've got a gearbox that's failed this morning as you've gone into the factory. You have to get back up and running by tomorrow morning. So you're expediting a part, maybe from somewhere else, a completely different country. The carbon footprint now of getting that gearbox to you from, maybe across the continent or maybe even across somewhere else in the globe is huge. So being able to preempt that and control when you need those parts and minimize the part consumption, you're taking away all that transportation carbon footprint in that logistics supply chain. But I think these are things that maybe people don't naturally jump to is from a sustainability aspect. They're probably just thinking of what is the energy consumption at that factory today and how do we get that down? There's a lot of other dimensions here.
I guess the question would be, why is the focus on energy costs? It's going back 6 months to a year, it was on front page of news everywhere, around the world of energy prices going up. But I guess has it always been sort of something that's been a high focus, or is that sort of exasperated? I can't think of the word. One of them. But.
Yeah. But I think it has always been something that's been given attention, focus. But you're right. There's, as I say, there's some clients of ours that are very energy intensive organisations, and their entire focus was shifting from a board level to look for efficiency to drive down energy consumption within the factory, and that's completely understandable. And that this then introduces more energy monitoring, because in a lot of cases, maybe all you know is like what's the bottom line consumption across the entire factory for the month. It's very hard to get that granular view as to where that energy might be used. So this is again where if you've got some sort of digital infrastructure, some connectivity, you can start to monitor at quite high granularity where that use of energy is coming from. So in those type of organizations, you might be start to discover things that are not even related to predictive maintenance. You might be thinking, we leave this machine on standby overnight and it's consuming, 25, 50% of its normal operating power. Maybe if we actually just turned it off and then accepted that we needed like a 15-minute warm-up period in the morning before we get the factory up and running, you can be using less energy.
And of course, that's again, talking from a Senseye sort of specifically, that's something you can sort of tell the app as well. So it knows that, that there's a reason for this kind of activity or lack of activity is because this is a planned shutdown, etc. Right?
Yeah, exactly. And sometimes, just the triggering of the data needs certain parameters, so we wouldn't maybe see data during those downtimes. Or, we've got features where, you can put in your downtime schedule. And the app can know about that and make sure that it's not either telling you about missing data or it's got the context to know that you'll be going into a startup period at a certain time. So, and it can expect some unusual behaviour during that startup period.
And I guess back to so you mentioned sort of data again. At the point of when we're talking to customers or potential customers, what's sort of the process around transforming that data into usable data for predictive maintenance? I think we'll talk about sort of the Gen AI element in a sec, which is obviously very new, exciting for us as well. But I guess to start with, on that base level, what does that sort of process look like, Rob, in the initial engagements with customers?
Yeah. So the really important first aspect is focusing on the business problem you want to solve, right? So understanding what are the problems that are causing me pain. There's a lot of organizations out there that, they've maybe got a specific type of sensing, and that's what they'll apply. So maybe it's like vibration monitoring, but you don't always need vibration monitoring in every machine. But if that's the tool you've got, you kind of tend to come in with that. Whereas our approach is saying, let's have a look at the historic downtime reports and the historic maintenance records and find out where the business pain is. Then that leads us down the path as to what data do we need to avoid those things. And then once we start, we will look to say, like we say, what data is available in existing systems. We can implement some connectivity solutions in there, various gateways or industrial edge devices that can capture that information, apply some logic and pre-processing. These are just simple triggers, saying, well, send the reading at a certain point in time or only when the machine's running. And there can be more complicated, what we call, like virtual sensing or derived measures. Sometimes we even do that in the cloud, right? So we've got capabilities within the Senseye app where you can stream data at relatively high rates and do all that pre-processing in the cloud. So if you wanted to avoid that on the edge. But what the key thing here, though, is about making sure that data has those, leading indicators of failure and condition indicators that I was talking about earlier.
And then I guess, because it's funny enough, it's not something we push sort of heavily on the marketing side, AI, machine learning and stuff, because we are, and I think sensibly focused on the outcomes, because I like this analogy where you have a mobile phone, but you're not worried about how it works underneath the hood. As long as it's doing what you want it to do and it's, etc., then you're happy, right? But I guess because we're talking about AI, it's the topic of this conversation, I guess. So how does AI and the machine learning within Senseye sort of impact the sort of the data, then, transform the data, I guess, or play a part in transforming the data?
Yeah, and it's really core to what we do. I mean, we approached this in the early days when we started the Senseye as a company back in 2015, looking at this as a problem that needs to be solved at scale. And the only way really to solve this at scale is using technology and smart machine learning and artificial intelligence to fulfilling a lot of the mundane things that humans have to do, because humans don't scale, but we can scale with technology. So we can take a human that normally monitors 50 critical assets in a factory, but he's in a world now where he's got maybe 1,000 connected assets in that factory, and we can give him a tool now that allows him to have the focus on the right assets within there. And that's really where the AI and machine learning kicks in. Now, one of the reasons that we don't go heavily over on that, we want to talk about the use case and the outcomes that we get from our solution. And we don't expect our users to be AI or machine learning experts, right? We don't want them thinking about things like having to train models. We have automated this in the background. And that's been a really key aspect for us, is using that really smart technology, but then thinking about how do you deliver the end outcome in as simple a way as possible, and hiding a lot of the complexity that's required from the user and automating it as much as possible.
And so we follow that in the next step, which you announced this week, the new sort of Gen AI functionality within Senseye as well, which is a big step forward. Obviously, I get, it's bold to say, big step forward in the predictive maintenance market. I mean, maybe you could explain a little bit about that and maybe how that could link with sustainability outcomes, I guess, specifically.
Yeah. So I mean, from our perspective, the recent sort of releases of this generative AI and large language models capability, what it's really done is it's accelerated things that we wanted to do already, problems that we were trying to solve. Like, how do you make use of a lot of that knowledge that exists within the maintenance team and across maintenance teams in different factories within a customer's organization. We've always had a focus on connecting up to maintenance systems and gathering feedback from users, and be thinking, right, how do we leverage this knowledge and actually provide that out to enable what people describe as more prescriptive type of maintenance. So as well as having predictive maintenance in when does the maintenance need to happen, if you can actually start to get somebody towards, and this is what you need to do. So try to prescribe to them the action that they need to carry out. And what's been fantastic really is the alignment of what we're able to do now with Gen AI and large language models. It fitted exactly inside the philosophy that we had within Senseye, and it's helped it to accelerate that roadmap. And like I say, we're coming out now with our first productionized versions of that. We've been working for the last sort of 18 months or so on prototyping and designs as to how that should all work for the user. But maybe we think from, I don't know, like a sustainability aspect. You've got the ability now to have information at your fingertips that maybe you would have to have some expert come out. And so you've got a lot of remote support that can take place. So maybe people aren't having to travel so much. But if we can actually get people, and maybe this is a more tangible aspect, to the solution quicker, then they can resolve the problem quicker and avoid sort of a lot of wasted time and wasted effort. So we've seen cases, and this has been not just within our Senseye client base, but throughout my career, where when people are like troubleshooting and problem solving, you're going in and typically, changing components or trying things out and spending a lot of time, maybe wasting spare parts, wasting production time by trying to troubleshoot and get to the core of what actually needs to be resolved on this machine. By pulling knowledge and pooling, as in a central resource repository, and then being able to pull that knowledge out into insights for the user, if you can get them to a solution quicker, it can only be much more efficient in every dimension, whether it's sustainability, organizational, and financial.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.